So let's continue with our discussion on hard disk, okay, magnetic disk, and we'll be talking about this ARM scheduling algorithms. Now before we go into these different algorithms, we need to know first of all what is disk scheduling. Disk scheduling is nothing but basically a scheduling process which has been performed by the operating system to schedule input-output requests that are arriving from the disk, especially from the magnetic disk. Now this scheduling is also known as input-output scheduling. Now why this scheduling is very important? Because the reason that there are always multiple input-output requests that are arriving from different processes, and usually at one specific point of time only one input request can be served by the disk controller. Thus the other input-output request needs to wait in the waiting queue and needs to be scheduled. Now there are two or more requests, okay, which may be far from each other. So in order to achieve great disk arm movement, this scheduling is always required. And also another reason is that since hard drives are considered as one of the slowest part of the computer system, so there's a requirement that there should be some specific way how to access those information, okay, in an efficient manner, and for that this scheduling is required. So for this we depend on what we call disk scheduling algorithms or disk arm scheduling algorithms, okay, for the purpose of seeing that how input-output requests can be achieved efficiently by reducing the total time of any input-output request. And the time required to read or write a disk block is determined by three factors. One is seek time, where this is nothing but the time taken for a disk drive to locate the area on the disk where the data is to be read or to be read is stored. Number two, rotational delay. This is nothing but the amount of time between information requests and how long it takes the hard drive to move to that sector where the requested data is located. In other words, there's nothing but a time measurement in milliseconds of how long before a rotating drive can transfer data. And then you have the actual transfer time, which is nothing but a time taken for a data transfer between the drive and the host system. Now of all these factors, seek time dominates a lot, okay, and any error checking, suppose if input-output request is going to have any possibility of an errors, that is being done by the controller so that efficient satisfaction of input-output requests from the hard disk is performed. Now the first scheduling algorithm is called the first come first serve disk arm scheduling algorithm, and this algorithm works in this way where the disk driver accepts requests one at a time and carries them in that order, okay. Now as far as this algorithm is concerned, to optimize the performance of the seek time of the hard disk, little can be done with this algorithm, okay. Now however, another strategy is possible when the disk is heavily loaded. Now it's likely that while the ARM is searching a particular sector based on one particular input-output request, other disk requests may be generated by other processors. And usually many disk drivers maintain a table indexed by cylinder number with all the pending requests for each cylinder chained together in a linked list headed by the table entries, okay. So given this data structure, FCF first come first serve can be improved. To see how this algorithm works, consider an imaginary hard disk which consists of 40 cylinders, okay, and let's say a request comes in to read a block on cylinder 11. Now while the input-output the read-write head of the hard disk is performing the task of searching this cylinder number 11, okay, some more requests are coming from some other user processes, okay, and that is to read data from cylinder 1, 36, 16, 34, 9 and 12 in that order. Now when the current request is finished, it is completing reading a block from cylinder 11, the disk driver has a choice of which request to handle next, okay. Now using first come first serve, it would often go to cylinder 1, then to 36 and so on and so forth respectively, for a total of 111 cylinders that it will be reading, okay. Now how do we get to this 111? Okay, it is nothing but the sum of all those total cylinders that are being read. So first we have 11, okay, then you have 1, then you have 36, then you have 16, and then 34, 9 and 12. So if I want to know how many total cylinders are being read in total, starting from the first cylinder to the last cylinder in the form of the input output request, we have to take the total. So here 1, 2, 8, 14, 18, 18, 18 and this is 9, 18 and 9 will give us 27. Okay, 6, 7, 8, 8, 14, 18, 18 and 19 will give us 27. Okay. 3, 6, 7, 8, 9, 10, 11. Oh, so it should be 119 cylinders. Okay. Now alternatively, it could also handle the closest request next to maximize seek time. Now given the request, the sequence is 12, 9, 16, 1, 34 and 36 as shown in the jagged line. Now with the sequence, the arm motion will be 1, 3, 7, 15, 33 and 2 for a total of 61. Okay. So this is how it works. Okay. That is basically the arm motion is nothing but the subtraction from the first, like in this case, okay, the first cylinder being read is 11, right? So the arm motion from 11 to 12 is a difference between these two, so this gives us 1, and from 12 to 9 this will give us 3, from 9 to 16 this will give us 7, and 16 to 1 will give us 15, and then 1 to 34 will give us 33, and 34 to 36 will give us 2. And we take all these totals, this will give us the total cylinders being read. And the same case is applicable here. You just have to subtract, sorry, I've made a mistake here. So from 11 to 1 this will give us a difference of 9, and 1 to 36 this will give 35. So we take all those differences and the total will give us the total cylinders, the disarm motion, total seek time, okay, as you can call it. Okay. Now another algorithm is the shortest seek first, which cuts the total arm motion almost half compared to first come first serve. So what it does is that it handles the closest request next. That is from 11 it will move to cylinder 12 and so on and so forth. Now this algorithm, however, has a problem. That is, any request which is far from the middle will always get poor service. Okay, there is requests at either extreme end would have to wait until a statistical fluctuation in load causes there to be no request near the middle. Okay, so this is how the shortest seek first disk scheduling algorithm works. So it starts from cylinder 11, then you move to 12, okay, then 15, 10, then it goes to 16, then 2 or 1, sorry, and it reaches to 34. So this is how it works. Now another algorithm is the elevator algorithm or the scan algorithm, okay, which determine the motion of the disk arm and head in servicing read and write requests. Now this algorithm works in the same way as the behavior of a building elevator, where the elevator will continue to travel in its current direction either up or down until empty, stopping only to let individuals off or to pick up new individuals heading in the same direction. So this algorithm requires the software to maintain one bit called the current direction bit. Whether the current direction it's moving is up, so it will continue satisfying all the cylinders requests that are in the upward direction and followed by down. Now whenever a request finishes, the disk or elevator driver checks the bit. If it is up, the arm or the cabin is moved to the next high pending request, not the lowest pending request, but a high pending request. If no requests are pending and higher direction, then the direction bit is reversed. Okay, so consider this example here. Okay, so using the the elevator algorithm here. Okay, suppose the direction bit is set to up. So the initial cylinder from where the request is being indicated is 11. So it will move upwards. That means that always to the highest pending request. So the highest pending request that follows after 11 is 12. So it will go to 12, and then from 12 it will move to 16. From 16 it moves to 34, from 34 it moves to 36, and from 36 it moves to 9 because there is no other high pending request. So from there it moves to cylinder number 9, and from 9 it goes to 1. Okay, so from here you'll get basically, okay, what are the differences of, you know, the disarm motion. So from 11 to 12, this is 1. From 12 to 15, 16, sorry, this will be a difference of 4. And from 16 to 34, okay, 16 to 34 will give us 18. And then from 34 to 36, this will give you 2. And then from 36 to 9 will give us 27. Okay, and then from 9 to 1, this will give us a difference of 8. So the total this movement will be 1 plus 4 plus 18 plus 2 plus 77 plus 8. So this will give us the total disarm motion. Okay, so this is how, you know, the different disarm shielding algorithms are used to move around the given, you know, cylinders, okay, based on the read-write head, based on the request that is being made. Okay, so this is about disarm shielding algorithms. Thank you.